Okay, the time has come. We have to do the responsible thing and do a three-dimensional finite element analysis of our 3D model using a Helmholtz-based acoustic differential equation type of setup. Thank God we don't have to do this by hand. So we have some free utilities. One is called Elmer, it's free. The other is called Paraview, it's free. So what we're going to do is we're going to take our 3D model. We're not just going to take our full step assembly and just throw it into Elmer. No, it doesn't work that way. I wish it did. What we have to do is we have to model the volume of water. So in this case, it's going to be a sphere. If we move to a parabola, it would be two parabolic hemispheres. We have to model that, export it as a step file, import that into Elmer, mesh it, and then once we've meshed that, we have to create this Helmholtz differential equation setup with boundary conditions. In this case, the boundary conditions mean that what the water is going to do when it's driven by the two hemispheres, and then the water itself, right? So in this case, we want to have an antinode on each hemisphere. So we have to set that up as a amplitude and phase shift in those boundary conditions. Create the simulation file, and then once that's all created, you're going to run that file. And then when you run that file, you can see it calculate all the differential equation stuff. Then you have to open the output of that in Paraview, and then you have to do a whole bunch of stuff to be able to see what you're looking at. It doesn't just pop up into some pretty picture. So that's where I'm at. I've got something coming together here. This is for the long haul, just to put it into the repo so that if you want to simulate a different type of geometry, you can go ahead and do that. The responsible thing to do is to simulate this before I machine a different set of hemispheres. Also, I want to know what's going to happen in the existing hemispheres. So that's the reason for the simulation. That's why it's been a couple days since we've had a video update, because I've been shoehorning this into my brain as fast as I can.